Welcome to all of you on this YouTube channel. Today we are going to talk about measurement in science and technology. So first of all we try to know about what is science. So science is a systematized and organized knowledge about the various natural phenomena which is obtained by careful experimentation, keen observation and accurate reasoning. So science is come from a Latin word that is scientia or scientia, that means to know. In Sanskrit we call sastra and in Arabic we call ilm. Both means is organized knowledge. So we talk about science, then we also try to know about what is physics. So physics is the branch of science that deals with the study of basic laws of nature and their magnificent in various natural phenomena. So actually, why we call it law of nature? So if we see that from the ancient time to till now, what we try to know, as a curious person we observe natural phenomena and we choose a particular phenomena and continuously observe that phenomena. From that phenomena we try to understand that phenomena and then we describe it, on which basis we give some laws. So it is about nature, so we call it laws of nature. So if we observe nature or any phenomena, we try to measure it. If we measure anything, yeah, any substance, then we call it a physical quantity. So how are we measure it? We measure it in numbers and using a unit, that is measuring unit. So how we actually measure anything else? Actually we measure a unknown quantity with a known quantity. If we measure unknown quantity with known quantity, then we define it numbers, how many numbers we measure it, such as we use a unit, that is kilometer. And we if a person or a car travels a few distance, then we define it in a number, that is 1 kilometer, 2 kilometer, 3 kilometer. This is many times of the kilometer. So science and technology help us making precise measurement for our daily life activities such as stitching, cooking, sports, shopping, traveling. Actually, if we cooking, we make any food, then what we did, we did we try to understand how many how many things we need to make a food and what is the quantity should be that particular ingredient. And if we go to the sports shop to buy a shoe, then we try to know what is the number of your uh, feet. So if we go on the shopping, for shopping, so what we try to do there, if we try to measure some things such as rice, sugar, etc. If we're traveling, then we give also example of measurement of unit in kilometer, in centimeter and etc. So uh, let's try to understand one more example from physicists strive to develop a clock of extreme accuracy so that any time or time interval can be precisely determined and compared. You may wonder whether such accuracy is actually needed or worth the effort. Here is one example of the worth. Without clock of extreme accuracy, the global positioning system, that is GPS, that is now vital to worldwide navigation, would be useless. So it is one of the excellent example of the measurement. So in the next slide, we try to know about fundamental and derived quantities. Actually, fundamental quantities are those quantity that is not derived from any quantity, that is known as also base quantity. So, uh, fundamental quantity is only seven. All the rest of all the rest quantity are derived quantity from uh, from the fundamental quantity. We define derived quantity by multiplication and division. The unit defined for fundamental quantity are fundamental unit, and those obtained for the derived quantities are called derived unit. Fundamental quantities are also called base quantities. So, in 1971, the 14th General Conference on Weight and Measurement picked seven quantities as a base quantity, thereby forming the basis of the International System of Units, abbreviated SI, from its French name and popularly known as the metric system. The unit for the three base quantities are length, mass, and time. Actually, these length we measure in meters, time measure we second, mass we measure in kilogram. But here are the seven fundamental quantities, that is mass we define for it a base unit, that is kilogram, and symbol kg small letter, length meter, symbol small m, time fundamental unit second and symbol small s, temperature fundamental unit होगा इसका second, sorry, Kelvin, symbol capital K, electric current fundamental unit ampere, symbol A, luminous intensity fundamental unit candela, symbol small cd, amount of substance fundamental unit mole, symbol mol, mole, small letters. So there are also some supplementary fundamental quantities, that is plane angle, that is we measure in radian and symbol rad. Second is solid angle, we measure it in steradian, symbol small sr. So if we try to measure any distance or anything else that is necessary, we try to understand that the physical quantity or in easier way. So as we try to understand from our atom to our galaxy or universe, then we see that 10 to the power minus 15 to 10 to the power approx 50, that is the length of the universe. So here we see that actually it is a lot, a very large number. If we put one, then after that we put 50 zero, that is confusing. So here what we did, we use some prefix to define that large quantities. So here uh, we what we did as a further convenience when dealing with very large or very small measurement, we use prefix listed in the table. As you can see, each prefix represent a certain power of 10 to be used as a multiplication factor. Attaching a prefix to an SI unit has the effect of multiplying by the associated factor. Thus, we can express a particular electric power as 1.27 multiplied by 10 to the power 9 watts equal to 1.27 gigawatt equal to 1.27 gigawatt GB capital. Thank you.